Welcome to this lesson on symmetry. There are different types of symmetry if you look on your definitions. The definition itself of symmetry is a figure has symmetry if there is an isometry that maps the figure onto itself. You might remember from a previous definition, isometry is a transformation for which the image is always congruent to the pre-image. So same shape and size, but it's either going to be rotated or reflected or translated. Those are different isometries. So symmetry is a figure that has, if there is an isometry that maps the figure onto itself. So here are three different types of symmetries. Number 11, reflectional or line symmetry. A figure has reflectional symmetry if there is a line about which the figure can be reflected onto itself. The line of reflection is called the line of symmetry. So notice here in this trapezoid that we have, if you cut the trapezoid in half like such, then you can basically fold it, fold it onto itself, and it'll fit perfectly. Notice that if you try to find a line of symmetry horizontally like this, if you fold this down, it's not going to fold perfectly onto itself. The only line of symmetry would be this line right here. So that's reflectional symmetry. Rotational symmetry. A figure has rotational symmetry if there is a point and degree measure of 180 degrees or less for which the figure can be rotated onto itself. Now it's important 180 degrees or less because, for instance, you don't want 360 degrees because every image, if you rotate it 360 degrees, a complete circle would have rotational symmetry. So you have to go 180 degrees or less. So if you look at this figure, the point is in the center of the figure. The degree measure, notice maybe if we rotate it this way, and this point will rotate and match with that point, and then you'll have the exact same shape, and it'll look exactly the same. So that would be rotational symmetry. Now, to figure out the degrees, if you think a full circle is 360 degrees, notice you have 5 points that are identical looking. So you would divide by 5, and you would find that your degree is 72 degrees, and we went counterclockwise. It would also be 72 degrees clockwise. And the last type of symmetry is point symmetry. A figure has point symmetry if a half turn maps the figure onto itself. So the previous example, rotational symmetry, can be any degree 180 degrees or less, compared to point symmetry is a half turn. It has to be a half turn. The center of such a rotation is called the point of symmetry. So again, we have a point of symmetry right in the center there. And if we do a half turn, hopefully you can see this top. If we do a half turn, we'll now be at the bottom, and the sides will be in the same spot. So it'll look exactly the same with point symmetry, 180 degree half turn. So those are our last definitions that we have in this chapter. Just a couple examples. Which figures have reflectional symmetry? How many lines of symmetry does it have? Remember, reflectional symmetry, you have to map it onto itself. So if you try to do a line through the house like that, there's no way, a horizontal line through the house. If you fold the top of the house down onto the bottom of the house, it's going to look the same. The only one you'd have is splitting the house perfectly in half like this. So if you were to fold the house, reflect the house over this line, you would get the exact same overlap. On the next one, it looks like an equilateral triangle. We could have a line of symmetry right here. You can imagine if you fold along that crease right there, you would get the same shape on both sides. It would be a right triangle. It looks like you could also have a line of symmetry that goes through here. And if you fold along that line, it would map onto itself. And then you also have a line right here Notice they're concurrent at a point. We talked in a previous chapter about that concurrency. And it looks like these would be medians. So this point would be the centroid, just to mention a term that we had previously. Number 3, there are quite a few lines of symmetry. Looks like you can cut the x like that. You can cut the x like that. You could also cut through this way. So if you fold it, it would map onto itself perfectly. Fold that way. Are there any others? It doesn't look like there would be any others. If you try to go from like this corner to this corner, it doesn't look like it would map perfectly onto itself. So you have 3 lines of symmetry. Now number 4, can we find a line of symmetry for that? If we try to go down maybe this way, and if you imagine folding it, it's not going to map onto itself perfectly. If we try to go across this way, it doesn't look like that's going to map perfectly either. So this actually has none. It has no lines of symmetry, reflectional symmetry. The next example is which figures have rotational symmetry. Draw in a point of symmetry and state the least number of degrees that would rotate the figure onto itself. Now remember, rotational symmetry is the one where you need 180 degrees or less. So all of these will rotate if you put a point right in the center of this house and try to rotate this 360 degrees. Sure, everything's going to work 360 degrees. But which figures have rotational symmetry? Now if you try to rotate the house 90 degrees, the house is going to be fallen over, maybe because it was built on the sand. If you rotate it 180 degrees, the house is going to be upside down, like the disciples turning the world upside down in their preaching. I'm not really sure. But this would have no rotational symmetry. The only one would be 360 degrees, which doesn't really count as rotational symmetry. The next one, this definitely does. If you put a point in here and you rotate, say counterclockwise, you rotate this vertex to be now the top vertex. This would have rotational symmetry. The way you figure out is you take 160 degrees is a whole full turn, full circle. And if you have 3 common points like this, you're going to divide by 3. So you'd say 120 degrees counterclockwise or clockwise. It doesn't really matter. Mainly it's the degree. I'm not too concerned about clockwise or counterclockwise. 120 degrees. Number 7. You think if you're going to rotate this one to be over here, since these are identical, you can rotate this. So it would be a yes, rotational symmetry. 360 degrees divided by 4 common edges. So we would have 360 divided by 4 is 90 degree rotation. And then number 8, it looks like, for instance, if we went 90 degrees, it wouldn't be enough. It would be vertical instead of horizontal. But we could go 180 degrees. So this would be a yes. We rotate 180 degrees. Which of the above figures has point symmetry? Again, to remind you, point symmetry is figure if it only does a half turn. So we can actually go back and notice the degrees that we mentioned. Half turn, this would be a no on a half turn. Half turn, if you did a half turn, these 2 vertices would be at the top and this vertex would be at the bottom, so that would be a no. Half turn on this actually works for a half turn. 2 90s would have a half turn, so we would say this is a yes with point symmetry. And we'd also say, since we already found this is 180 degrees, this would be a yes. So you're kind of looking for like 90 degrees or 180 degrees rotational symmetry would give you point symmetry. On the next page, drawing in lines of symmetry. I'll give you a chance. See if you could draw some of those lines of symmetry for 9 through 14. You might want to use a pencil in case you get a wrong answer. But see if you could do 9 to 14. Pause this video. Okay, for lines of symmetry, this is not equilateral. So we really only have 1 line of symmetry. If you try to do one of those, it's not going to map perfectly onto itself. The next one, there's only 1 line of symmetry, right through the center like that. For this one, the A has 1 line of symmetry. Now the next one looks kind of like a rhombus. So you could, hopefully you got this line of symmetry. And you also notice this line of symmetry. The question would be, are there any other lines of symmetry? And it appears that those are the only ones. If you try to go through the center like this, it doesn't look like it's going to map perfectly. You could take this paper out of your binder and try to fold it. And if you try to fold it halfway down this side, it's not going to map perfectly onto itself. And likewise, if you try to go this way, it's not going to map perfectly onto itself. For the next one, it doesn't look like we could actually divide that way, because this is going to be down here. It's not going to hit this point like it should. So it doesn't look like the diagonals are going to work. And if we try this line, you can imagine trying to fold it. It looks like this acute angle will be lying on top of an obtuse angle, which is not a good sign for symmetry. So we'd say there are no reflectional symmetries, lines of symmetry. And lastly, for the star, let's see, we can have this one, we'll cut it in half, and similar thinking, we can go through any of these vertices. So you actually have quite a few lines of symmetry. So far we have 5 lines of symmetry. And are there any others? It looks like those are the main ones. Those are the only ones for lines of symmetry. Lastly, name each degree measure for which the figure has rotational symmetry about the marked point in the center for each, and tell whether the figure has point symmetry. So rotational symmetry is 180 degrees or less. Point symmetry is a half turn, 180 degrees. Why don't you pause this video and I'll let you see if you could determine the rotational symmetry and the point symmetry for each of these 3. So for the first, notice you have 4 identical looking sides to this shape. So if you rotate it like this, it's going to look like the exact same shape. So you would have 360 degrees as a full turn divided by 4 congruent looking sides. So you would have 90 degrees is the rotational symmetry. The point symmetry, yes or no on point symmetry? Point symmetry would be a yes. You could think of rotating this another 90 degrees. So 2 90s is 180, and you would have the same looking shape. For number 16, rotational symmetry, it's going to be, you can think of this opening right here on this side as similar to the opening on this side. So we would take a 180 degree turn, 180 degrees rotation to map this image onto itself. And the point symmetry would also be yes, because that is 180 degrees. The next one looks like we have 2 squares. So if we rotate this vertex onto that vertex, that would be rotational symmetry. So if we had 360 degrees is the total full circle. And we have 1, 2, 3, 4, 5, 6, 7, 8 vertices that are similar. We divide by 8. So that would be, let's see, 360 divided by 2 is 180, divided by another 2 is 90, divided by another 2 is 45 degrees. 45 degree rotational symmetry. And we would say, yes, it has point symmetry, because if you do, how many 45s? If you do 4 45s, then you would have rotational symmetry.